All right, let's get into it. Today, we're putting on our detective hats. Our case? Unlocking the secrets that are hidden inside a dataset using a really crucial skill called exploratory data analysis, or EDA for short. So, you've got this pile of data, right? Maybe it's a spreadsheet, a database, a file just full of numbers and words. And sure, it's a collection of facts. But hidden within all those rows and columns are patterns, secrets, and believe it or not, actual stories. So the big question is, how do you get your data to talk? We are going to tackle this just like a classic detective case. Here's our game plan. First, we'll get our mission. What even is EDA? Then, we'll have the briefing, where we get our case files straight. After that, it's the investigation, which is all about cleaning the evidence. Then, the fun part, the interrogation, where we find the clues. And finally, the debrief, where we tell the story of everything we've discovered. Okay, first step, the mission. It's time to understand our assignment. Your role as a data detective officially begins right now. So what exactly are we talking about here? At its core, EDA means getting to know your data. It's that absolutely critical first step where you just kind of poke around, you ask some basic questions, and you create simple visuals just to map out the territory, long before you start building any complex models or making any big decisions. I love thinking about it this way. EDA is your very first conversation with your data. I mean, you wouldn't make a huge life decision based on a rumor from a stranger, right? You'd investigate first. Well, EDA is that investigation. It's that initial chat to understand its quirks, its strengths, and yeah, its weaknesses. All right, mission accepted. Now for the briefing. Every good detective starts by carefully reading the case file, and that is exactly what we are going to do. The briefing has three parts. First, we have to know what we're trying to solve. What is the central question here? Second, we need to understand our evidence. What does each column in our data actually mean? And third, we just take a quick peek at the raw data, to see its size and shape and get a feel for what we're working with. Having a clear goal is just crucial. For our case, we'll be working with a data set of student information. Our guiding question is simple, but it's super powerful. What factors are related to a student's exam score? That gives our whole investigation a purpose. And this is what we see when we first crack open the file. A table with rows and columns. We've got student IDs, scores, majors, but hold on a second. Take a look at that third row. The hours underscore studied field is just blank. That's our very first clue that this evidence might not be as perfect as it seems. And that leads us right into the investigation. This is where the real detective work starts. We need to take our messy, imperfect evidence and make it clean, reliable, and completely trustworthy. And let me be really clear about this. This is not an optional step. Data collected out in the real world is almost always full of typos, missing information, and all sorts of strange entries. Ignoring this is like building a case on contaminated evidence. It's just not going to hold up in court. So, what are we looking for? Well, let's meet the four usual suspects. Missing values, like that blank spot we just saw. Incorrect or inconsistent values, like a typo. Duplicate records. And outliers. These are values so extreme they just look suspicious. Simple fixes can make a huge difference. A typo like Miami with 2 eyes, that's an easy correction. An impossible value like a negative age of -23, come on, we can flag that as missing. This whole cleanup process is what makes sure our analysis is actually based on reality. And then you find something like this, an outlier. Did a student really study for 1,000 hours? Almost certainly not. This is probably a data entry error. Maybe someone just added an extra zero. A good detective doesn't just delete this, they investigate it and try to correct it if they can. Now, the investigation isn't just about cleaning, it's also about making the data more useful. This often means transforming it. For example, if you have columns for quantity and price, you could create a totally new total underscore price column. It's like combining two pieces of evidence to create a brand new insight. So, with our evidence now clean and organized, it's time for the interrogation. This is the part where we start asking the really pointed questions of our data to uncover those hidden patterns and clues. We start by interrogating each variable, or each column, on its own. This is called univariate analysis. Think of it like looking at one suspect at a time. What's the typical exam score? What's the range of hours studied? What's the most common major? A simple bar chart is a perfect tool for this part. Just by looking at the major column, we immediately find a clue. Computer science is the most common major in our dataset by a lot. That's really important context for our investigation. But the real magic happens when we bring two variables into the interrogation room together. This is bivariable analysis. We're asking how two pieces of evidence relate. Does one influence the other? This is where we find the connections that can crack the case wide open. And in our student data case, this is the breakthrough. When we compare hours studied and score, we find a really clear pattern. Students who study more tend to get higher scores. The connection is made, case closed. Well, almost. We've cleaned the evidence and we've found the key connection. The final step in any good investigation is the debrief. It's time to summarize our findings and finally tell the story of the data. So, what's the final report? We started with a messy case final, full of errors and missing info. After cleaning the evidence, we interrogated the data, and we uncovered the key to the mystery. While many factors might be at play, our investigation confirmed a crucial link. More study time is strongly associated with better exam results. That is the story our data had to tell. Exploratory data analysis isn't just some technical process, it's a mindset. It's about being curious, thorough, and methodical. Every dataset has a story to tell. By following these steps, you can become the detective that uncovers it. So, the only question left is, are you ready to listen?